to Think Maths. We are in class 10 Maths, chapter 10, Circles. In this session, we are going to discuss about Theorem 10.2. So, what is Theorem 10.2? The lengths of the tangent drawn from an external point to a circle are equal. What do you mean by lengths of the tangent? So, it is nothing but, so if there is a point, external point P. So, P is an external point from the external point to the point of contact. So, this Q is the point of contact. Another point of contact is R. So, PQ is the length. So, length is nothing but from the point of contact to the external point. So, this distance PQ is called the length of the tangent. So, the length of the tangent drawn from an external point. From an external point, we can draw only two tangents. So, we have drawn PQ and PR. So, we have to prove that this distance PQ equal to PR are equal. So, now this is the circle with center O. So, let us assume what are all given? A circle with center O. So, this is given. Next, let us take PB and external point. So, external means outside. So, P is outside the circle. So, let P be an external point. Then, PQ and PR are two tangents. These are all given. Okay. We have to prove these two tangents length. PQ is equal to PR. Okay. Now let us construct. That is, what is the construction? From the center, we are going to join all these 3 points P, Q and R. That is, join OP, OQ, OR. Okay. So, OQ, OR, OP. So, we are joining OP, OQ, OR. So, before getting into the proof, let us write the construction. So, construction, join OP, OQ, OR. Okay, children. So, let me start the proof. Here, what is OQ? OQ is the from the center to the point of contact. So, OQ is the radius. In the same way, OR is also the radius. So, OR is nothing but from the center to a point on a circle. So, OR is also the radius. So, we know from theorem 10.1, so radius is perpendicular to the tangent at point of contact. So, this radius is perpendicular to PQ at this point of contact. So, this angle is 90 degree. In the same way, radius OR is perpendicular to the tangent PR. This is because theorem 10.1. So, OR is perpendicular to PR at the point of contact R. So, this makes R 90 degree. So, we can write angle OQP equal to 90 degree and angle ORP. Angle ORP equal to 90 degree. This is because radius is perpendicular to tangent at point of contact from theorem 10.1, which we discussed in previous video. So, this is 90 degree. Now, let us consider two triangles PQO and POR. These two right angle triangles, and if we prove these two triangles are congruent by CPCT, we can say PQ and PR are equal. So, let us take the triangle in triangle OQP. OQP and another triangle ORP. ORP. We have these two angles are same. Both are 90 degree. Angle OQP and angle ORP both are equal. So, we can write angle OQP equal to angle ORP both 90 degree. These two angles are equal. Now take this OP. OP is also in the triangle OQP. It is also in the triangle ORP. So OP equal to OP. So this is the reason is it is common. Now take OQ and OR. Both are radius in the same circle. So radius is constant for the circle. OQ is also a radius. OR is also the radius for the same circle. Then OQ and OR will be equal. So we can write OQ equal to OR. The reason is radius of the same circle. So radius of the same circle will be equal. So here an angle is equal which is 90 degree and this OP is the hypotenuse side. 90 degree opposite side. OP is the hypotenuse side. It is common. Next a side OQ and OR are equal. So in 90 degree, that is in ninth standard we have studied right triangle, that is right angle, and this is hypotenuse, and this is a side, that is RHS. So by criteria RHS, these two triangles are congruent. This we have studied in ninth standard. So we can write as triangle OQP congruent to triangle ORP. This is because by RHS. One is right angle, another is the hypotenuse side, another is a side. Okay. So these three are equal. So we can say triangle OQP is congruent to triangle ORP. Okay, children. If this is congruent, we know that PQ will be equal to PR. PQ equal to PR. This is by CPCT. That is by corresponding parts of congruent triangles are equal. So we have PQ is equal to PR. PQ is the tangent and PR is also the tangent, and we have proved that the length of the tangents are equal. So with this we have completed theorem 10.2. Thank you. Hi friends, this is my YouTube channel Think Max. If you like my videos, just show your support by subscribing to this channel and hit the bell button so that you get the notification whenever I upload my videos. So these are the playlist in my channel. So if you want, you can check out the playlist. So there are some playlists on Class 10 Max, Chapter 9, some applications of trigonometry, and you have all the playlist for sample question paper, and this is the playlist for introduction to trigonometry. In the same way, there are playlist for each chapter for Class 10 Max, and also there is a playlist for Math Olympiad questions. So if you want, you can check the playlist. Thank you.